Hello and welcome back to math. We're doing it real old school. Oh. Hi. Alright, so we're going to talk about a little bit about absolute value. When something is, it just is, right? Our number line, we talk about adding things, we talk about subtracting things, and we give them positive and negative values in a string of different actions, right, and operations. But this marker exists. Here's another one, it also exists. They both are here. There are two of them. It doesn't matter if I have them or if you have them, there's still two markers. There's an absolute nature to them. They exist. Mathematically, we call this absolute value. So, what does that mean? This is our symbol. We put bars around the number, okay? So if bars are around the number, what we're saying is, I want to know what is the actual value, tangible value, whether I own them or you own them, of these markers. So the absolute value of 2 is 1, 2. 2. I have them. I have 2 markers. Well, what if I give them to you? Now 2 markers are over there. They're in your world. Go ahead and pick them up. Here. They're yours. Go ahead. Go ahead. A blue and a black. You have them now. But what's the value of this negative? If from my perspective, I'm calling it a negative because I gave them away. They're devoid from me. But the actual value of the markers is still 2. Absolute value. Now, here's the deal though. If we're doing algebra, and I say the absolute value of this unknown thing is 2, well, what does that mean? It means x might have been 2, but x might have also been negative 2. So we have to count for them both. So we say x equals 2. That's correct. Or x equals negative 2. It equals that. I don't know which one it is. And I never will. And I'll say check the solutions and one of them's wrong, but if I put 2 in for x, I get 2. If I put negative 2 in for x, that works also. They both count. Let's look at this example over here. Do you see it? Can you see it? Let's zoom. Shall we zoom? Zoom. Zoom. There it is. Let's look at that. So, 4n plus 5 minus 7 is 29. This is the absolute value bars. Now, I know some of you are going to want to use the distributive property because what operation is happening right here? That's a multiplication, right? And we can distribute, Ms. Thompson. No, you can't. If you distribute this, you will get one of the right answers, but you will absolutely lose the other. And you can't do that because that means then it's wrong. So here's how we approach this. You treat this whole thing like it's a value, right? The whole absolute value thing. Let's let n plus 5 equal x. So we'll just solve for x and then we'll deal with this. That's sort of like what you want to do in your brain. So leave this alone for a bit. If you said 4x minus 7 equals 29, we can solve this pretty easily in 2 steps, can't we? Add 7, add 7. For x equals 20, oh, doesn't equal 29, equals 36. Divide by 4. Divide by 4. X is 9. But x isn't 9 because we don't want x. We want n. And what was this whole thing? All right. It's an absolute value. It's an absolute value. Can you see me down here? Absolute value, n plus 5 equals 9. Let's zoom on that. Well, I'm in the way. Let's zoom on that. Who's zooming who? You know what I mean? So, here's the spot where you're going to split it. You say n plus 5 is 9, or n plus 5 was negative 9. We don't know which one it was. We have to have 2 answers. So now we solve these. N is 4, or n is negative 14. Now, this is all a long way away of saying n is 5 units from, or rather, 5 is 9 units from what we want. So it's either negative or positive. I think I said that wrong. I'm going to cut that out. That's absolute value. Let's look at our journey again, shall we? Bah, humbug. There it is. Ba-ding, ba-dang, ba-done. Absolute value. 2 markers.